Hi, I'm Emerson.
And I'm Emma.
We will be talking about the mole and molar conversions.
So the definition of a mole is a name for a specific number of things.
And you can represent moles by MOL. So, for example, 1 dozen equals 12 things, and 1 mole equals 602 hexillion things.
So when we're talking about moles, there's this thing called Avogadro's number, and that is represented as 6.02 times 10 to the 23rd power. And basically this is when you are using what you would use during molar conversion.
Then, moving from that, we go to molar mass, which can be represented as mm, and the definition of that is how much 1 mole weighs in grams, which is represented as G.
Okay, so now we're going to talk about conversions. So how we're going to convert when we're doing this is we're going to use dimensional analysis, which you should have already learned. If you don't know how to use it, that sucks. There's probably another video for you to use for that. So how you go into it, the steps are, if you're starting from grams, if they give you a number of grams, you always go to moles first. So you're going to start with grams, and then you're going to go to moles.
Which is represented by x grams over 1 mole. And then for Avogadro's number, with dimensional analysis, you go from moles to molecules. Always if molecules are involved, you know that's Avogadro's number. And that's 6.02 times 10 to the 23rd power over 1 mole.
So now we're going to do some examples because that's kind of just the whole layout. So she's going to show you your computer. Okay. You want to guess what?
Yeah, so first example is how many grams does 1.7 moles of NaCl weigh? So first you have the 1.7 moles of NaCl, then you have to go to grams. So you get 1 mole of NaCl, and with molar mass, you see how much 1.7 moles of NaCl weighs. And so you do your 22.99 plus 35.45 and equal 58.44, which is right here. And that's the grams of NaCl. You times this by this, and divide by 1, and you will get 99 grams of NaCl.
Okay, now let's do numero 2 example. Okay, so this looks like this. Okay. So, the question is, how many moles are in 14 grams of CO2, which is also carbon dioxide? So how we're going to do this is we're going to take what they give us, which is this little 14 grams, and we're going to put it first on the dimensional analysis.
Railroad tracks.
Yeah. So, first we're going to find, because we always have to go to moles, we have to find the molar mass, and it is depicted down here how we do it. So the C is 12.01. And then the O is 16.01, but we have 2 of those, so we're just going to multiply that by 2, which gives us 44.03 grams of carbon dioxide. And then we're going to put that moles of carbon dioxide. And then we're going to pop that down below right here, because it's always going to be a cross, because we're going to be getting rid of these little units right here. So, and then that's going to be underneath 1 mole, because anything under here is how much is in this. So 1 mole of CO2 would be this. So then we're just going to multiply across using our rules for dimensional analysis. So we're going to do 14 times 1 divided by 44.03, getting this, which is 0.32 moles of CO2.
Yeah, and then next, after this video, you'll have 10 practice problems to do, and we have an answer key. Thank you for watching.
Yeah, I hope you learned everything you need to know.